Hi everyone, welcome back to the channel. Sorry for not posting the video for the long time. Hereafter I will post the video continuously. Today we are going to clone this Raven website which I found very interesting, so why not try it. This is the website and my version of the website which is here, and we will build this interactive website by using Three.js, React Fiber and GSAP. If that sound awesome, please hit the like button and subscribe. Let's get started. We first start with the Blender by creating the 3D model required for this website. Let me clear this default settings and let me add the plane with a size of 52 meters something. 50, it's fine, 50 is fine. And let me go to the top view. I am creating multiple tabs for my convenience for adding shaders plus UV map. Let me first create a material for this. I will name it as circuit. I will rename the mesh name also as circuit. Let's add the image texture for this material and connect the color to the base color. Before opening the image, I will show this image I got from ChatGPT by entering multiple prompt and reference images. So let's attach this image. Okay, the texture is attached perfectly, so it's time to create the component placed upon the circuit. So let us first add the cube. Delete the unnecessary face under the circuit on the top also. Okay, this looks good. Let's rename the cube to box bottom. Let's duplicate this. And also let's rename box top. It's time to create the material for this too. Same way we need to add the image texture for this also by connecting color to the base color. And for this texture I have downloaded from the free pick. So like randomly you can pick whatever you need. This is the texture I have downloaded from the free picks, like black and white and gray. Depending upon the color, the light will get illuminated. Like white color means the illumination will be more, gray means a little bit less illumination, and black means very low illumination compared to the remaining color. So I have chosen this textures which looks good. Okay, it looks good. Same way we need to create texture for the top mesh also. For this I will add my logo, which I converted my logo into black and white. Same way, like black will be less illuminant and the white will be more illuminant. The logo is not looking good, so we need to do UV map. The logo is in upside down direction, so let's me rotate. Let's confirm everything looks good. Okay, everything looks good. It's time to duplicate these two meshes and place it in the remaining part of the circuit. Okay, it's quite looking good. Next we need to add the camera. You may have a doubt why we need camera, like our web application logic depends upon the camera movement based upon the scroll. Like I will place the camera by first year, and then next year likewise I will add the 5 camera here, and I will store that 5 camera position and rotation in a variable, and then based upon the position and rotation, when we scroll, we will switch from one camera to another camera position rotation. Likewise we need to do. So if you don't like this approach also, you can do without the camera also, but in this video I follow this approach. From next video onwards we can do different approaches also, so it's not a problem. Let me add a camera. Okay, we have added all the 5 camera, so it's time to put our model into glb file. I will first click as a remember export. We first need all the selected object, and the data property we need a camera, and we need a compression for reduce the file size, and I will name it as circuit.glb. I make a new folder, name it as Ravando, and I will open that in my VS Code editor. To create the Next.js application from scratch, we need to enter this command npx create next tab. We are not going to use TypeScript for this project, so no. Okay, our project get installed. Before that, we need necessary package for our application. First package is React 3 Fiber and React 3 Drei, and the core package 3, and GSAP for animation, and we need Postprocessing and React 3 Postprocessing, which is used for effect like bloom effect, like glowing effect. I will show in the video. Okay, the package is get installed. Let's start the application by running this command npm run dev. Our application is running successfully. Let's remove the boilerplate code. The layout is fine, no problem with the layout. And go to the global.css file and remove all the css except the report tailwind css. Okay, everything is got cleared. Let's create the component folder with the file name of homepage. Let's import this home page in the page.js. Yeah, home pages came in our browser, so it's get imported properly. And we need to create another file called experience. That experience is specifically for the 3D part, and this home page is specifically for the HTML render, like adding the paragraph h1 tag, everything. Yeah, let's create the experience file name. And this I will remove div and add the canvas element, which will come from the React 3 fiber. Let's check the browser whether the canvas element is added or not. There is only empty thing, so let's open the inspect tab and click. Oh, I forgot to import the experiences. Let's import this experiences file in the home page. So let's check the browser whether the canvas element is added or not. We face the error like create context is not a function, like we are using the Next.js 15. So before importing any other component or hooks, we need to first make sure this is a client file. I will use this command to make it as a client file. So no, the error is gone. Let's inspect. Yeah, the canvas element is added, but the width is full but height is not full. Let me go to the home page. Since we are using the tailwind CSS, we can use like this 100 view width and height 100 view height. Yeah, the canvas element is having the full height and full width. Inside the canvas elements, we need to add the circuit component which we didn't create yet. Let's create a folder called 3D, and inside that I will make a file name as circuit.js. Inside this we will do our 3D logic. Okay, let us put the circuit.glb which we created in the Blender application to the public folder. Make it as models. To import the model, we need to use GLTF, which will be from the drei package. We get this scene. Create the primitive element object props, pass the scene object. Let us check the browser whether the model is imported or not. Yeah, we can see the model is get imported, but we can't move or rotate anything. So let's use the orbit control in the experience file. Import the orbit control, which will come from the React grid. Now we can successfully zoom out, zoom in, or rotate. Everything we can do, but everything is black, so we need to add some lighting. Let's add the ambient light. Finally, we will remove this light. Yeah, let's import everything for the model to get animated. Import the circuit texture. Let me add the chip to the public. Create a folder named textures, and then move the chip.webpack to the textures folder. So we can add this circuit texture to the circuit mesh. By this code, if there is no scene written, which is the circuit.glb, I am doing scene.drivers, which is like a map method, and we will get the object name in. So we are adding object.material equal to circuit material, the circuit material which is not created yet. Let's create the circuit material. I just paste the circuit material. Don't worry, we will explain everything in step by step. For this code to work, we need uniform. I will paste the uniform and then I will explain the code in and out. Okay, let's start with the uniform. Why we need uniform is we need to communicate between the shader code with the JavaScript code. You can see there is a more object, which is utime, u position 1, position 2, position 3, 4, 5, and wave size. Okay, these are the property I have created. I will explain it when we go to the circuit material. Okay, I just created 3.mesh standard material. For that map is circuit texture we created previously, and the metalness and roughness and emissive map, emissive intensity, and the roughness and normal map will be added finally. These are the property to make the material dot on before compile. Why I'm doing this is, on before that material is compiled, we need to do our custom logic, like moving the circuit, like flowing the current in the circuit, like that animation we are doing, right? So we are doing like before the material is it compiled, we are going to update their fragment shader. If you don't understand the shaders logic, please check out this video I have shown. Okay, let's continue. Shaders dot fragment shader equal to fragment shader dot replace the common which will created as a function, created as include common, which is it will be already present in the mesh standard material we are using here. Mesh standard material, for your clarification, I will go to the node modules and find out the three package we have installed, and go to the source, go to the renderers, go to the shaders, and go to the shaders chunk, and we are searching common. So find out where is the common. We can see there is common.glsl.js. This is a common, like here they are defining pi value, a reciprocal pi value, and everything with power value, power 2, what is the like a common function or common variable they created in this file by Three.js, which is done by default by Three.js. So we are going to take that module and we are going to add our custom function in that. So this is the process of doing hash include common, and then we are going to replacing with the hash include common, and we are adding our custom uniform flow due time position 1 position 2 by we are passing the uniform here, and this is a function we are creating as a common. By adding this circuit material, what's going on with the browser, so we can see everything is just placed, but the current is only is not flowing. Why it's not flowing is this u time is not just get updating. We will update it finally, but what's going on with this code, to understand what going on with this code, I will change the circuit.webpack to one white image. I have created the white image and I will put it in the textures folder. Let's change from circuit.webpack to white. We can see some circle thing is going on. One circle here, one circle here, here. Totally 5 circle are going. This 5 circle based upon the during position 1, position 2, position 3, 4, 5. Based upon this, the radial circle which is placed here. So the radial logic is which is created by this create wave function. Same way we are replacing the emissive fragment, and which will also present in the, and we can see here emissive color equal to texture 2D emissive map, and we are passing the UV, and it will return the total emissive radiance. Same ways we are also doing the same logic, like a texture 2D emissive map which will be passed. We are passing that the same circuit texture. So we need to do animation, so let's increase the u time by putting it in use frame. We can see the animation is flowing. Okay, let us put back the circuit texture instead of white texture, and we can see texture is get flipped. So let us make the flip to false. So everything is looking good. Only problem is we can see the radial animation too, but we don't need to see the radial animation. So in that place this code will be helpful. Like doing the condition, if you meet the threshold of 0.6 with the scale of red, then multiply with the emissive color, else don't need to multiply, else put it as 0. So we are only getting the flow between the wires, remaining part get 0. Okay, everything looks good. Okay, let's then work on the box bottom. Let's add material for the box bottom. So we need for this texture we are going to use a square noise. This is a texture we got from the free pics. And I have pasted the material, like in this uniform we are passing the square noise texture and the color A, color B, which is like a combination of yellow and blue. This is our custom shader material, so there is no material dot on before compile like 3 mesh standard material. As usual, we will add the vertex shader and the fragment shader. There is the default code of the GL position projection matrix into model view matrix into vec4. In the fragment shader, the logic applies, like we are getting the texture by from the uniform, and we are mixing the color with color A, color B, and texture red. Let's see the combination. So we can see the color. Okay, let's continue. Then remaining part, which is top of the box, we need to add material for the top of the box. I have created the mesh standard material, no shader logic in this. We only need the logo texture, so let's create the logo texture. So let me add the logo which I have created, and let's connect the top box material with the object dot material. So we can see the texture is getting flipped, so let's flip the texture to false. Everything is looking good. Let's move to the post processing. This is a post processing effect composer which will come from the React 3 post processing. Based upon this, we'll get the bloom effect. You can see everything is getting updated, like the flow of current plus the illuminating under the box bottom. Okay, it's looking good. So next step is to do the camera animation based upon the scroll. It's time to remove the orbit control now. Okay, after commenting the orbit control, let me go to the circuit file, create a camera transform. In this camera transform ref only, we are going to store all the camera position and rotation. So let's go to the use effect, which we traverse the scene, clone all the position, rotation and quaternium, and push it to the camera transform, which we created camera transform ref. And using this transform, we are going to do GSAP animation. Let's import the GSAP plus ScrollTrigger package, because based upon the scroll we are going to animate. So we need ScrollTrigger. Go to the use effect, command it as GSAP animation. We are going to code in the same use effect to create the GSAP animation. Before that, we need to go to the home page, and we need to create totally 5 section with the height of 100 view height, because we are going to scroll the section, not the canvas. So let me paste the code here. There is totally 5 section, as you see here. Section 1 is for hero, about, front and back end technology. These are the text we are added in this section, and with the height of 100 view height. Let's check the browser. You can see the text but not canvas. This is the UI based upon the section, but we need to scroll further to see this. So we are going to make the canvas as fixed. You can see every text is comes above the canvas. So we are currently scrolling the section only, not the canvas. So based upon the scroll, we are going to animate the canvas camera. So let's go to the circuit file and go to the use effect. I am pasting this GSAP code which is mapped to the section class name which we defined here. There are totally 5 sections, so we are mapping through each section. We are getting the camera transform values by pausing the index, and based upon the scroll trigger of each section, we are animating the camera position and rotation. by pausing the camera transform position and rotation. So let's check the browser. Camera is not defined. Yeah, I need to import the camera from the use 3. We have just imported the scroll trigger, but we are not registered the scroll trigger plugin. It's actually it is working, but quite not well. So let's increase the field of view of the camera. Yes, it's looking good, but the background is, we can see the background is white color. Let's change the background color to black. Looking good. If you like the video, please hit the like button and subscribe. And mainly, if you have any idea for the next project, need to comment it. I will definitely make the video to clone that website. Yeah, thank you.